Good morning, guys. So what we're going to be working with today for discrete math, it's something that seems weird. You've never heard of it again, but it's something that's also not difficult at all. It's a lesson that's called bin packing, right? And what bin packing represents, it's a way to actually just be able to arrange things into containers, right? But our goal is always to be able to arrange things into the least number of containers, right? That's what bin packing is. It's a method of arranging terms, grouping terms into the least number of containers, Again, shouldn't mean anything to you yet, but I will show you it's not difficult whatsoever. It's actually pretty simple when you get the hang of it and see it. So again, there are two ways that we can actually apply bin packing, right? One is called the first fit model. And the second one is called the best fit model, right? And the best fit model is the one that we're going to focus on the most, just because it literally tells you itself. It's the best fitting model, right? So it's always useful to be applying the model that always works the best for all the situations. So the difference, when it comes to first fit model, the first fit model is literally tells you, you go in order that the numbers are given to you, but you literally put them in the very first container that it'll fit. So even though it may not be the best container to fit it in, if it fits in the first one you see, you put it there, right? That's why it's called the first fit model. You put it in wherever it fits first. The best fit model is different, and that's what we're going to focus on. The best fit model literally tells you that you want to put terms, you want to put numbers into the containers that it fits the best. And that's what our goal is always to do, always to arrange things the best way possible, right? So first fit, it's wherever it fits first. Best fit, it's wherever it fits the best, right? So we're going to focus on the best fit model right now in terms of being able to arrange terms, right? And I'll show you what I mean. So I'm going to be giving you a couple of numbers, and what bin packing is going to tell us is we're going to try to arrange those numbers into the least number of containers, but also the best way, right? So I'm going to give you, let's say this, I'm going to give you a few containers, right? I'm going to call this a container, I'm going to call this a container, and our goal is going to be to try to put these numbers that I'm going to give you into the least number of containers, right? But arrange them the best way possible, right? So we have 5 containers. I'm going to tell you this much. Each container is only going to be able to hold a total of 20, right? And again, even though I gave you 5 containers, doesn't mean we're going to use all 5, right? So we have 5 containers. Each one can hold a maximum of 20, right? I'm going to give you now 4 numbers. I'm going to give you now 5 numbers. I'm sorry. Those 5 numbers are going to end up being 15. It's going to end up being 6, 12, 2, and 7, right? So there are the 5 numbers that we want. So what bin packing is saying is we want to take those 5 numbers and we're going to want to try to organize those numbers into the least number of containers the best way we can, right? Basically what it means the best way, try to take it in, and our goal perfectly, it would be to try to fill up each container as best as possible by not having anything left over. So best goal possible, since each container can hold 20, our ideal situation would be that we can get numbers that add up perfectly to 20, because if it adds up perfectly to 20, it means it fills that container perfectly, right? So that's our goal. And we always go first number, right? We always go in order of the numbers, right? So let's get started. Again, we want to organize this into the least number of containers. We know that each container holds 20, and we'll see how many containers we can fit in, right? So first number, we see 15, right? So 15 is the first number. We know that we can put the 15 in here, just because, again, this container can hold up to 20. That number is 15. That fits perfectly in there, right? So we've arranged the first one. Got rid of the 15. The next one is the number 6, right? So if you go 6, we know that 6 can't fit in here. And the reason we know that 6 can't fit in here is because 15 plus 6 is 21. We can't have 21 because each box can only hold 20. So if we can't put 6 here, we go to the next one. We're going to put 6 here, right? So we know again, 15 we have there, 6 we have there. We couldn't put them in the same one because 15 plus 6 is 21. You can't have more than 20, right? Next one, we have 12, right? We know again, 12 can't fit in here because 15 plus 12 is more than 20, so it can't go in here. We know that 6 plus 12 is 18, so it can go in here, right? We can fit that in there. Again, because 6 plus 12 is 18, this can hold 20, we're still good, right? Now we go to the next one. And this is where the best fit model actually is different from the other one. We have 2. We look here, we see that 15 plus 2 is 17, so it would fit here. And if it was the first fit model, it would say just put it there because it's the first box that it can fit in. But what we're doing is we're trying to fit this the best, right? We know that this has, we know that this has 15, right? We know that 6 plus 12 is 18. If we're trying to arrange the 2, we would want to put the 2 here. And the reason that we want to put the 2 here is because 6 plus 12 is 18. 18 plus 2 is 20. That can hold 20. So since it already adds up to 20, we know that we fill this container perfectly. Can't take any more. There's nothing left over. That's always our goal for the best fit model. We try to fit it and fill it up completely so that nothing is left over. So even though we could have put the 2 here for the best fit model, it's always best to try to fit them into the ones that hold it perfectly, right? And we know it's perfect because 6 plus 12 is 18. 18 plus 2 is 20. Filled it up. Now the next one, we have 7, right? 7 we know can't go in here because 15 plus 7 is more than 20. Can't go here because that's already full, right? This one here is already full. So we'd have to put 7 there. So again, if we're trying to analyze this, we know in order to fit those, we would need 3 containers, right? We would need 3 containers. And that's the idea of the best fit model. It's basically trying to see where we can fit all these numbers the best way possible, you know what I mean? And in this case, we were able to fit all 5 numbers into 3 different containers. Let's try one more, guys, just for you to actually feel comfortable working with this. Right? Let me get rid of the terms that go over inside. Just 1 sec, just so I actually don't have to keep drawing this over and over again. So we got that. And now I'm even going to change this, right? Because now I want to create a different situation where instead of each container holding 20, it's now going to hold, just so it doesn't look so dirty for you guys. Now instead of each container holding 20, what I'm going to want to do is I'm going to want each container to hold a total of 10, right? I'm going to want each container to hold a total of 10. Let me use a green. So this is going to hold 10. That's going to hold 10, that's going to hold 10, 10, 10, right? And now, same situation. I'm going to end up giving you 5 numbers because our goal is going to end up being able to try to fill those numbers in the best way possible, right? And the numbers that we have are 8, 3, 4, it is 9, and 2. So again, we're going to try to fit these numbers in the best way possible into these containers, right? How many containers is it going to take for us to fill this up? And just like we did before, we're going to use the best fit, go 1 by 1, and then see where they fit in, right? First number is 8. We know that 8 is going to fit in the first one, just because the first one holds 10. 8 fits in there perfectly, right? We're done with that. Next number is 3. We know that 3 can't go in here because 8 plus 3 is 11. Can't hold more than 10. So if it doesn't fit in the first one, just put in the second one, right? Next one, we have 4, right? 4 again. We know that 8 plus 4 is 12. We can't have more than 10, so it can't go in here. We know that 4 plus 3 is 7. It can fit. We can put 4 right there, right? Next number, we have 9. We know that 9 plus 8 is 17. Can't fit. We know that 3 plus 4 was 7. 7 plus 9 is 16. Can't fit there. So if it can't fit there, we have to go here, right, where it's empty. You got that one. Now it's the 2. And again, I always say this. Technically, where does the 2 fit the best, right? The 2 can fit here. The 2 can fit there. Can't fit there. So now think, would the 2 fit better with the 4 and the 3, or would it fit better with the 8? And so we know that it would fit better with the 8 because 8 plus 2 is 10. Right? 8 plus 2 is 10. It can fill 10. So right now we know it's perfect because there's nothing left over in that bin. It's filled perfectly up, right? And that's always our goal. We could have put it here. 3 plus 4 was 7. 7 plus 2 is 9. It would fit. But it fits better here because there's nothing left over. 8 plus 2 is 10. That's always our goal. So in the end, same thing. We had 1, 2, 3 containers. 3 containers to fill this up. And that's the idea of bin packing, guys. It's how many containers you need in order to be able to arrange terms, the least amount of containers. Again, hopefully this helped. Let me know if you guys need any help on anything.